Section 4.2. We're doing example 3 now. We've got another theorem to put in our electronic notebook. It's called the exterior angle theorem, but before we jump into that theorem, I do want to talk to you about the anatomy of a triangle. And that's what this paragraph is all about, and I wanted to go through that with you. The interior is the set of all points inside the triangle itself. Exterior is all the points that are outside of that. And I don't know why that line just showed up, so I apologize for that. It just popped up there all of a sudden, but that exterior is outside of it. So an interior angle is going to be angles that are inside the triangle. Exterior, think, okay, it's outside, and if I extend one of the lines, then the angle that's outside here is an exterior angle. If I extended this line like that, this would be an exterior angle. If I extended this line, then this one would be an exterior. Are you catching along? You know, kind of catching what I'm showing here. Or as my brother would say, are you picking up what I'm putting down? Okay. I just need you to recognize where your exterior angles are and where your interior angles are. Okay. Now, and probably the most important part of this is the understanding of these last two lines. Each exterior angle has two remote interior angles. Remote means kind of far away from it, the farthest away from it that you can get. A remote interior angle is an interior angle that is not adjacent to the exterior angle. Okay? So if we look at angle 4, which we know is an exterior angle, 3 is adjacent, okay? 3 is not a remote interior angle. 1 and 2 are the remote interior angles. And so that is, I need you to understand the anatomy so you don't choose the adjacent angle as one of your remote interior angles. Okay, so let's talk about this exterior angle theorem. It's really cool, the relationship that happens here. The measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. So if you look at the triangle that's given here, here's your exterior angle. So there's angle 4. So the measure of angle 4 is going to equal to, and you're going to add angles 1 and 2 together because they are remote interior. 3 is adjacent. We can't use 3. 3 is right next to 4. We cannot use that. That's an interior angle, but it's not remote. It's adjacent. So we would add 1 and 2 together, and if we know those angle measures, then we can figure out what angle 4 is equal to. Or if we know what angle 4 is equal to and one of the other two, then we can figure the other missing one. Okay, so let's apply this theorem to this next problem. They want us to find the measure of angle J. So this is what they're asking us to find right here is what I've got circled. There's angle J, and angle J is 5x plus 17. So what do we know? Angle J is a remote interior angle, and angle H is a remote interior angle to this exterior angle 126. So we can create a math problem because we know that if we add the remote interior angles to each other, just like this, they're going to equal the measure of the exterior angle. And you can create a problem just from that exterior angle theorem. All right, so let's add like terms. 6x and 5x is 11x. Negative 1 plus 17 is 16. Okay, we have a two-step equation from here, so let's take away 16. We've got 11x is equal to 110. Divide each side by 11, and it looks like x is equal to 10. Now, you do have to ask yourself this question, is this what they're asking me to find? Do they want me to just find x? And the answer is, well, no. They want to know what the measure of angle J is. So we're going to have to substitute that 10 into the 5x plus 17. So we're going to do 5 times 10 plus 17. And I've got 50 plus 17, which is 67 degrees. That's what they're after right there. They want the actual angle measure. And if you can find x, then you can find the actual angle measure. All right, I'm going to leave the next one here for you to try. Apply the exterior angle theorem to the check it out. And that'll be a bonus for you.